with the 0.3635 value. Now the next question, which is question 4b, prove that the power in a pure inductive circuit is 0. This is very important question and many times asked in our exam. So now we step by step prove that value. This is the figure for purely inductive circuit where your voltage is V of t equals to Vm sin omega t. This is applied voltage to the circuit. Now due to that the current flowing through the coil is IR, and magnetic field generated is surrounding with indicated with the dotted line, and the magnetic flux is also given in this circuit. So for pure inductive circuit, the voltage given to that circuit is V equals to Vm sin omega t, and due to that the current passing through that circuit, that is I equals to In sin omega t minus pi by 2. So using that equation, now we know that the P is nothing but the product of V and I. So here we are getting the V and we are getting the I. So by taking the product of that V and I, we are getting the power. So here P equals to Vi. So put the value of V, that is Vn sin omega t, and put the value of I, that is Im sin omega t minus pi by 2. Friends, as we all know that sin omega t minus pi by 2 is nothing but the minus cos omega t. So instead of using the sin omega t minus pi by 2, we are putting the value of minus cos omega t into equation of power. So we are getting that P equals to minus Vm in sin omega t cos omega t. Now taking the denominator and numerator 2 with the we are getting that P equals to minus Vm Im by 2 into 2 sin omega t cos omega t. So 2 sin omega t cos omega t is again the mathematical equation, that is sin 2 omega t. So using that equation, P equals to minus Vm Im by 2 into sin 2 omega t. Omega t is your theta. This is the angular frequency. So the average value of the power is the total area covered by the signal, that is 0 to 2 pi. 0 to pi is the half wave, and pi to 2 pi again half wave, positive and negative. So combining this two, 0 to pi and pi to 2 pi, 0 to 2 pi is the total area of convergence. So P average equals to an integration of 0 to 2 pi minus Vm Im by 2 sin 2 omega t. So put the value of Vm Im by 2 is a constant, so kept it is from the outside the integration, and put the value of 2 pi into equation of sin 2 omega t. So sin 2 pi, value of sin 2 pi is also 0, and value of sin 0 is also 0. So ultimately Vm I minus Vm Im by 2 into 0. So all the terms are become the 0. So ultimately we prove that the average value of power in pure inductive circuit is always 0. So this is the purely inductive circuit, the power is 0.
What is true RMS and why is it important to us?
Sometimes it is very much required to transform a delta connection in an electric network to star for simplifying it. For delta to star transformation, we will first consider 3 points A, B and C on a network where a delta is connected as shown. Here, resistor R1 is connected across points A and C, resistor R3 is connected across points C and B, and resistor R2 is connected across points B and A. Now, suppose an equivalent star is connected in place of the delta, and we have to calculate the resistance of each arm of the star in terms of each resistance of that delta. Let arm of resistance Ra of the equivalent star is connected with point A, arm of resistance Rb of the equivalent star is connected with point B, and arm of resistance Rc is connected with point C. Now think about the resistance value of the delta across points B and C, and as you see from the diagram, there are two parallel resistive paths across B and C. One path is through resistor R3 and another path is through series combination of R2 and R1. Hence, the equivalent resistance between these points will be parallel combination of R3 and R2 plus R1, and this is equal to R3 into R2 plus R1 divided by R1 plus R2 plus R3. Now, think about the resistance value of the star across same points B and C. As you see from the diagram, there are two resistors RB and RC across the points B and C. Hence, the equivalent resistance between these points will be series combination of RB and RC, and this is equal to RB plus RC. Here RA will not come into our calculation as it is just open circuited. Since the two systems are identical, resistances measured between points B and C in both of the systems must be equal. So, RB plus RC is equal to R3 into R2 plus R1 divided by R1 plus R2 plus R3, and say this is equation 1. Similarly, if we think about the equivalent resistance of delta and star respectively in between points C and A, we can prove that RC plus RA is equal to R1 into R3 plus R2 divided by R1 plus R2 plus R3, and say this is equation 2. When we think about points A and B in the diagram, we can similarly prove that RA plus RB is equal to R2 into R1 plus R3 divided by R1 plus R2 plus R3, and say this is equation 3. Now, if we add equations 1, 2 and 3, we shall get 2 into RA plus RB plus RC is equal to 2 into R1 into R3 plus R2 into R3 plus R1 into R2 divided by R1 plus R2 plus R3, or RA plus RB plus RC is equal to R1 into R3 plus R2 into R3 plus R1 into R2 divided by R1 plus R2 plus R3, and say this is equation 4. Now, if we subtract equations 1, 2 and 3 from equation 4, we will have respectively RA equals R1 into R2 divided by R1 plus R2 plus R3, RB equals R2 into R3 divided by R1 plus R2 plus R3, and RC equals R3 into R1 divided by R1 plus R2 plus R3.